In this video, we're going to calculate the acceleration of an object from a data table. Now, the important thing to remember is that acceleration is the change in velocity per change in time. Another way, again, to think about that is that acceleration is how fast the velocity increases or decreases. Now, to calculate the acceleration, I need to have at least 2 points. So I'm going to choose 2 points arbitrarily. It doesn't matter which points that I choose as long as I'm consistent. So I'm going to choose my initial velocity in time as t equals 0 seconds, and my initial velocity is 0 meters per second. Then I'm going to arbitrarily choose this point here. So if I summarize that data, my initial velocity is going to be 0 meters per second when t equals 0 seconds. And in this case, my final velocity will be negative 10 meters per second when time t equals 2 seconds. Now the total time change between these 2 points will be 2 seconds, or delta t equals 2 seconds. This is the change in time. Now to calculate the acceleration, I'll do acceleration is the final velocity minus the initial velocity divided by the time it takes to change that velocity. Now in this case, my final velocity equals negative 10 meters per second, and I'm going to subtract my initial velocity, which in this case, my initial velocity is going to be 0 meters per second. And the time it takes to change this velocity, the time it takes to go from 0 meters per second to negative 10 meters per second, is 2 seconds. So I'm going to divide this change in velocity by 2 seconds. Now when I do that, what I'll get is negative 10 minus 0 is negative 10 meters per second divided by 2 seconds. Now negative 10 divided by 2 is going to be negative 5 meters per second per 1 second. So the velocity will change by negative 5 meters per second, or meters per second squared. Now I did not have to choose those 2 points to calculate the acceleration of this object. I'm assuming again that the acceleration of this object is constant. So in this case, let's choose 2 other points. So let's choose this point again, and I'm going to call this my initial velocity in the second case. And now let's choose this point as my final velocity in this case. So to summarize what I'm saying, I'm going to use an initial velocity of negative 10 meters per second, and that's going to occur when time t equals 2 seconds. And then I'm going to choose a final velocity of negative 20 meters per second. So v final equals negative 20 meters per second, and that occurs after 4 seconds have elapsed. Now one of the things that you should see is that it takes 4 minus 2, or 2 seconds to change this velocity. Now my acceleration, to calculate it again, will be the final velocity minus the initial velocity divided by the time it takes to change that velocity. And in this case, my final velocity is negative 20 meters per second, and I'm going to subtract my initial velocity, which in this case is negative 10 meters per second, and I'm going to divide that by the time it takes to change that velocity, the time it takes to go from negative 10 meters per second to negative 20 meters per second. And in this case, it will take 2 seconds. A negative times a negative is a positive number, so this will work out to be negative 20 meters per second plus 10 meters per second divided by the time it takes to change that velocity, which is 2 seconds. Now, negative 20 plus 10 is negative 10 meters per second divided by 2 seconds. And negative 10 divided by 2 is negative 5 meters per second, or meters per second squared. Now what you should see is that the acceleration is constant. It doesn't matter which points I choose. I'm going to find that the acceleration, or the rate at which the velocity is changing, is going to be constant. In this case, it's going to be a negative 5 meters per second every single second.